Hey, everybody. We're going to talk a little bit more about procedural fluency and mathematical reasoning right now. So let me just dive right in. So, procedural fluency means that the student demonstrates skills in carrying out procedures flexibly, accurately, efficiently, and appropriately. This is related to strategic competence and how well a student uses a strategy that makes sense to them. We must note that this might be standard or it might be invented procedures. It might use a strategy that involves tool use. It might involve pictures, numbers, words. It will not necessarily look like the standard algorithm. And remember that to be procedurally fluent, the young person needs to be able to solve the problem in a way that makes sense to them. And this will look different for all kinds of kids. And that was weird. Let's just close that. Sorry. Um, Here we go. Let's look at the next slide. So, NCTM defines it as procedural fluency is the ability to apply procedures accurately, efficiently, and flexibly to transfer procedures to different problems. So, if it works in one problem, can you make it work in another? And different kinds of contexts to build or modify procedures from other procedures. So, use what you know to do something you don't, and to recognize when one strategy or procedure is more appropriate than another. And sometimes both strategies might work really well for one type of problem, but they might not work as well for a different type. And so children will ebb and flow between strategy types depending on their understanding, depending on the rigor of the problem, and also depending on the structure of the problem, which we will get into later in the course. So, mathematical reason is a capacity for logical thought, reflection, and explanation and justification. It's the ability to formulate, represent, and solve math problems. So, this sort of connects strategic competence and adaptive reasoning. And if we think about the Grandma and Ivan and Acrobat problem, you all did a lot of reasoning in that problem because there wasn't a whole lot of computation that happened. So, that was a great example of using mathematical reasoning to try to solve the problem. And we will engage in some other number sense and reasoning routines throughout the year that will demonstrate how reasoning can often be more effective than computation to help one solve a problem. So there is no Jamboard entry for this video, but we will see you in video 9. Bye-bye.